We factor polynomials because we want to know what they're made out of. And it's the same reason you read the recipe for a cake. You want to know what it's made of. You want to know the pieces that make up the cake, that make up the polynomial. We have a checklist for factoring polynomials. And so we often remove the greatest common factor first. That's usually the best way to proceed. So in this first polynomial, I see a common factor of 4, and I see a common factor of y. Pulling out the negative sign will also make this look easier. So I'll take out negative 4y, which leaves behind 2y squared, plus 11y, plus 5. Mind your signs, positive and negative. Now we have a trinomial, a 3-term polynomial. It's quadratic. If I can break this down, it's made out of 2 linear pieces, 2 polynomials that are binomials of degree 1. I'm looking for ways to multiply to get 2y squared and to get 5. I don't have a lot of choices. 2y times y will produce 2y squared. If I want to produce 5, I have to multiply 1 times 5. See how I can make the 11 in the middle when I FOIL. Let's say 5 times 2y is 10y. 1 times y is 1y. 10y and 1y could make 11y if both these signs are positive. So this is completely factored. On our checklist, we always check for common factors, but these 4 terms in the second example don't have any common factors. I can still group them by first 2 and last 2, though. I see common factors there. And sometimes that points the way to continue. So if I'll take out a common factor of 9 and z squared, I'll also take out the negative sign. That leaves behind 2y. 2z, excuse me. You always have to mind what variable you're using. And negative 3. I'd like to see 2z minus 3 elsewhere. I'd like to see it after I factor out a common term in the last 2. They both share a 4. They both share an 8. Look deeper. They both share a 16. So let's take out a 16. And that leaves me with 2z minus 3. This is the signal that I've done something right. I have 2 large pieces, and they both share a common term of 2z minus 3. I can factor out that common term. Now that leaves behind 9, z squared, negative, plus 16. That looks a little backwards because of the minus sign and the plus sign in this order. I do see that I have 2 perfect squares. 3z squared is 9z squared. 3z quantity squared is 9z squared. 4 squared is 16. If I just wrote that as 16 minus z squared, 9z squared, I'd see the difference of 2 squares. And I have an expression, a way of factoring out the difference of 2 squares. I can write this as 4 minus 3z and 4 plus 3z. Along with I2 minus c. Now I know exactly what this second polynomial is made out of. Factoring by grouping sometimes allows you to identify smaller pieces that you recognize.